A little prank some kids like to play on snails is to pour salt onto them to make them melt. But have you ever wondered why salt would make this happen? Let's take a look at our friend Gary. Right now, he looks pretty happy. But what happens when we put salt on him? He melts. But why? If you take a look at Gary closely, you'll notice that his skin has tiny holes in it that let water go in and out. The water molecules are smaller than the salt molecules, so the holes are too small to let salt go through. So why would his skin have tiny holes in it to let water pass through? This is because water moves back and forth until equilibrium is reached. Equilibrium means that there are equal concentrations of salt and water on both sides of his skin. So if there is a high concentration of salt on the outside of his body, which means there's more salt than water on the outside of his skin, then water will go through the tiny holes to the outside of his body to make the two sides balanced again. So the water will move in and out the tiny holes until there's the same amount of water and salt solution on both sides of his body. So what happens to the balance of salt and water if there's too much salt on the outside because SpongeBob accidentally spills salt on him? There's more salt on the outside of Gary than on the inside of Gary. So which way will the water move through the tiny holes in Gary's skin to make everything balanced again? It'll move from inside to outside his body. This means that he's losing water, which makes it look like he's melting. This is just one of the many examples of the physical process called osmosis. Osmosis is the movement of water from an area of low concentration to an area of high concentration. Water moves through a semipermeable membrane. A semipermeable membrane, like Gary's skin, is a membrane that only allows certain things to pass through. In Gary's case, only small water molecules can pass through the tiny holes. Water moves through the semipermeable membrane to maintain concentration equilibrium. And that, my friends, is osmosis.